Now let's start with IUPAC formulation and nomenclature. That is how you write formulas and how from the formula you write the name of a coordination compound. So IUPAC formulation and nomenclature, it includes a set of rules which were decided by the Inorganic Nomenclature Committee of the International Union of Pure and Applied Chemistry. So these rules are the most updated rules which came in 2004. And we'll start with the rules for writing formulas if you are given a name. So first of all, formula of the cation is always written before the anion. I gave you an example before also, like if you talk about NaCl. In NaCl you write the sodium before chloride. Why do you write the sodium before chloride? Because sodium here is the cation and chloride is the anion. Similar rule is for coordination complex also, whether your cation is a complex or whether your anion is a complex. Either way, this rule is always going to be followed. For example, your cation is a complex. This is the cation and this is the anion. So you write the cation first. And like if you have the complex is the anion and the cation is a simple atom, then you will write the cation first, like KAgCN2. In this, potassium is your cation and the anion is a complex, but still we write the cation before the anion. The coordination entity is always enclosed in square brackets. The coordination entity here means coordination pair. We have already done this when we were talking about terms related to coordination compounds. So the central metal atom and the ligands attached to it, that is the secondary valency, is always enclosed in square bracket. The next rule is that within the coordination pair, the symbol of the metal is written first and then it is followed by ligands. Like you have a metal atom M and you have ligands L1, the L2 is another ligand, L3 is another ligand, so on and so forth. So first of all you are going to write the metal and then it has to be followed by ligands. So the next thing that people ask is, how do you write the ligands? If I have H2O as a ligand as well as NH3 as a ligand, how do I know which one to write first? Do I write metal NH3 and then H2O, or do I write metal H2O and then NH3? So this is addressed here. In it, it says the different ligands are arranged alphabetically according to the first symbol of the formulae. If you have different ligands present in your complex, you take the ligands like H2O or NH3 and you determine the first symbol of the formula. So H2O's first symbol is hydrogen and NH3's first formula is nitrogen. Now hydrogen comes above nitrogen alphabetically. So hydrogen, that is H2O, will be written before NH3. So the correct way will be similarly, if you have SCN, then the symbol of SCN will be S. If you have OH negative, the symbol of OH negative will be O. And if you have any hydrocarbons and carbon compounds, then their symbol will be C. Now the next thing which arises is, if two ligands have the same first symbol, then what are you going to do? How do you decide if you have to write the other ligand first or the other ligand first? Like you have ammonia, which is NH3, and you have N2. Both of them have the same first symbol, N and N. So how do we decide which one to write first? In this case, the ligand which has fewer number of atoms is written first. So in ammonia there is only one nitrogen present, whereas in N2 there are two nitrogens present. So ammonia will be written first, that is NH3 will be written first and N2 will be written after that in the coordination complex. Now the next thing is, if defining atoms of the ligand as well as the number of defining atoms are equal, Then the subsequent symbol decides the sequence. If you have NH3 and if you have NO3 negative. In NH3, the first symbol or the first atom is nitrogen, so the symbol is N. In NO3 negative also, the first atom is N, so the symbol is N. So they are N and N. So next we compare on the basis of the number of nitrogen. So NH3 also has one nitrogen, NO3 negative also has one nitrogen. So now what do? We go on to the next atom. We can see after NH3 there is hydrogen present. That is, in NH3 after nitrogen, hydrogen is present, whereas in NO3 after nitrogen, oxygen is present. Now hydrogen lies above oxygen in the alphabetical order, so NH3 will be written before NO3 negative. Remember, these rules are to be followed sequentially. The sequence that is given in the slides, these rules have to be followed in the exact sequence. You cannot just put the fourth rule above the first rule. So this is how you determine how the ligands have to be arranged when you are writing the complex. So the next rule states that polydentate ligands have to be also listed alphabetically. Polydentate ligands like your ethylene diamine, which is written in an abbreviated form as EN. Bipyridine, which is written in an abbreviated form as BPY, or tri-EN or di-EN. All of these are polydentate ligands. They also have to be arranged alphabetically. That is, if they are present together in a complex, which is actually not possible because they will exceed the coordination number, but hypothetically if they are present together in a complex, then BPY will be written first because it starts with B, that is bipyridine. After that we will write di-EN because it is diethylene triamine. Then we will write EN, and then at last we will write tri-EN. So the alphabetical order has to be followed for polydentate ligands also. Now the polyatomic ligands always have to be enclosed in parentheses or brackets. I can very well write this complex as COCl6 2 negative. That's very easy to write. I can do that. It will actually be 3 negative. So COCl6 3 negative. But in case I have a polyatomic ligand, that is the ligand which contains more than one atom, then that I'll have to write in parentheses. NO is polyatomic. It has to be written in parentheses. NH3 is polyatomic. It has to be written in parentheses. So you see, all the polyatomic ligands have to be enclosed in parentheses. The monoatomic ligands do not have to be enclosed in parentheses. There have to be no spaces at all in the ionic species in the formula. If you write CO, then you give this much space, write NH3 5, then you give this much space and write Cl, and then write 3 positive. This is wrong. There has to be no space at all between all the species present within your coordination pair, and even the species present outside your coordination pair. You cannot write Cl here. The Cl has to be present close to the bracket.